Now let's talk a little bit about WAN encapsulation protocols. We have different types of WAN connections, and on each WAN connection data is encapsulated into frames before it crosses that WAN link. And to ensure that the correct protocol is used, we need to make sure we're using the correct layer 2 encapsulation type. The choice of protocol depends on the WAN technology. It also is determined by the communicating equipment. And you'll see here we have either leased lines that's going between the two routers. That's HDLC, PPP, and SLIP. We have circuit switched, and that's going through the telephone companies. And then we have packet switched, and that's going through your service provider. The HDLC is the default encapsulation type on point-to-point connections, dedicated links, and circuit switch connections when the link uses two Cisco devices. That's important to keep in mind, Cisco devices. HDLC is now the basis for synchronous PPP used by many servers to connect to a WAN, and most commonly the internet. PPP provides router-to-router and host-to-network connections over synchronous and asynchronous circuits. PPP works with several network layer protocols such as IPv4, IPv6. PPP uses the HDLC Encapsulation Protocol, but also has built-in security mechanisms such as PAP and CHAP. Then we also have our Serial Line Internet Protocol, or SLIP, and that's a standard protocol for point-to-point serial connections using TCP/IP. SLIP has been largely displaced by PPP, so it's slowly becoming a legacy type thing. We also have our X.25 Link Access Procedure Balanced, or LAPB, and that is an ITU-T standard that defines how connections between the DTE and your DCE are maintained for your remote terminal access and your computer communications in public data areas. X25 specifies LAPB and a data link layer protocol. X25 is a predecessor to Frame Relay. With Frame Relay, it's an industry standard now for switch data link layer protocol that handles multiple virtual circuits. Frame Relay is a next generation protocol after X25, so the X25 is considered somewhat legacy as well. Frame Relay eliminates some of the time-consuming process, such as error correction and flow control, that X25 used. Then you also have ATM, and this is the international standard for cell relay, in which devices send multiple service types such as voice, video, or data in fixed lengths. They're 53-byte cells. The fixed length cells allow processing to occur in hardware, and it reduces the transit delays. ATM takes advantage of high-speed transmission media such as E3, SONET, and T3. A further look into the HDLC encapsulation, it is bit-oriented. Its synchronous data link layer protocol was developed by the International Organization of Standardization, that's the ISO. It uses synchronous serial transmission to provide error-free communication between 2 points. And it defines a layer 2 framing structures that allow for flow and error control through the use of acknowledgements. Cisco's developed an extension to the HLDC protocol to solve the inability to provide multi-protocol support. And with the Cisco HLDC, it's also referred to as CHDLC. Some of the differences there are within the header information, whereas in the standard HDLC you have the flag, address, control, data, FCS, and flag. With the Cisco HDLC, it uses a protocol data field to support multi-protocol environments, so you have the flag, address, control, protocol, then data, FCS, and flag. So the flag field initiates and terminates error checking, and the frame always starts and ends with an 8-bit flag field of 0, 1, 1, 1, 1, 1, 1, 0. iframes carry upper layer information and some control information. It sends and receives sequence numbers, and the pole final bit performs flow and error controls. Your S frames provide control information. It's the request and suspension transmission, reports on status and acknowledgement. It's the receipt of the iframe. And then in the U frame support control, the purpose they are purposes and are not sequenced. When we configure HDLC encapsulation, you have your default encapsulation method used by Cisco devices on synchronous serial lines. You have point-to-point protocol on loose lines between two Cisco devices, and connecting two non-Cisco devices use synchronous PPP. So with your router in config mode, you go into your interface and then you do encapsulation HDLC. Keep in mind again that HDLC is the default encapsulation on synchronous serial interfaces. You can do some troubleshooting on your serial interfaces when you do the show interface and then the serial interface that you're looking at. Different things that you can see within that is you can see whether or not your serial interface is up, if the protocol is up, which encapsulation you're using, and if it's the DCE, as you see here. It is also notated at this location with DCE version .35. The show interface serial command returns one of 6 possible states. You either have your interface up and up, down and down, up and down, up and up looped, up and down disabled, or administratively down and down. Of these 6 possible states, there's 5 problem states that we can see. And here we'll see what those are. You have your serial X is up, the line protocol is up, so there's no action required because everything is working. If the serial interface is down and the line protocol is down, the DTE mode, things you need to check. The router is not sensing a carrier detect or the CD signal, which means that the CD is not active. You either have a WAN carrier service provider problem has occurred, which means that the line is down or is not connected to the CSU DSU. You have cabling is faulty or incorrect, or you have a hardware failure has occurred. What you need to do there is you check the LEDs on your CSU DSU to see whether the CD is active, or insert a breakout box on the line to check for the CD signal. You verify that the proper cables and interface are being used by looking at the hardware installation documentation. Insert a breakout box and check all control leads. Contact the leased line or other carrier to make sure there's no problem that they're aware of. Swap out faulty parts. If faulty router hardware is suspected, change the serial line to another port. If the connection comes up, the previous connected interface is the one with the problem. Next, we have that the serial is up, the line protocol is down. Again, we're in DTE mode. A local or remote router is misconfigured. Your keep alives are not being sent by the remote router. A lease line or other carrier service problem has occurred, which means a noisy line or misconfigured or failed switch. A timing problem has occurred on the cable, which means that the serial clock transmit external, the SCTE, is not set on the CSU DSU, and the SCTE is designed to compensate for clock phase shift on long cables. And when the DCE device uses SCTE instead of the internal clock to sample data from the DTE, it's better able to sample the data without error, even if there is a phase shift in the cable. You could have a local or remote CSU DSU has failed. You could have remote hardware, your router hardware, which could be either local or remote, has failed. So what we need to do there is you're going to put the modem, which is the CSU or DSU, in a local loopback mode and use the show interface serial command to determine whether the line protocol comes up. If the line protocol comes up, a WAN carrier service provider problem or failed remote router is likely the problem. If the problem appears to be on the remote end, repeat step 1 on the remote modem CSU or DSU. Verify all cabling. Make certain that the cable is attached to the correct interface, the correct CSU, DSU, and the correct WAN carrier service provider network termination point. Use the show controllers exec command to determine which cable is attached to which interface. Enable the debug serial interface exec command. If the line protocol does not come up in local loopback mode, and if the output of the debug serial interface exec command shows that the keep alive counter is not incrementing, the router hardware problem is likely. Swap the router interface of the hardware. If the line protocol comes up and the keep alive counter increments, the problem is not the local router. If faulty router hardware is suspected, change the serial line to an unused port. If the connection comes up, the previous connected interface has a problem. Next, we have our serial is up, the line protocol is down. This is for DCE mode. The clock rate interface configuration command is missing. The DTE device does not support or is not set up for SCTE mode. And the remote CSU or DSU has failed. Add the clock rate to your interface configuration. If the problem appears to be on the remote end, repeat step 1 on the remote end. Verify that you have the correct cables. If the line protocol is still down, there's possible hardware failure or cabling problem. Insert a breakout box and observe leads. Replace the faulty parts. You can have the serial is up, the line protocol is up, looped. A loop exists in the circuit. The sequence number in the keep alive packet changes to a random number when a loop's initially detected, and if the same random number is returned over the link, a loop exists. Use your show run. Look to see what the loopback has been set to. If there's a loopback interface configured, use the no loopback interface. If there is no loopback interface configuration command, examine your CSU DSU to determine whether they are configured in manual loopback mode, and if they are, disable the manual loopback. After disabling loopback mode on the CSU DSU, reset the CSU DSU and inspect the line status. If the line protocol comes up, no other action is going to be needed. If upon inspection that the CSU or DSU cannot be manually set, then contact your leased line or carrier for them to start troubleshooting. You can have the serials up, the line is down, the protocol is down, and it's disabled. You have a high error rate has occurred due to WAN service provider problem, a CSU or DSU hardware problem, or the router hardware interface is bad. We're going to troubleshoot the line with a serial analyzer and breakout box. Look for toggling CTS and DSR signals. Loop CSU DSU with the DTE loop. If the problem continues, it's likely that there's a hardware problem. If the problem does not continue, then it's likely there's a WAN service provider problem. Swap out your bad hardware as required to fix it. And then finally, we have the serial is administratively down and the line protocol is down. The router configuration includes the shutdown interface configuration command, or you have a duplicate IP address. Check and make sure your interfaces all have the no shut. Verify there are no identical IP addresses using your show run or show interface. And then if there's duplicates, resolve it. And again, go to the no shut to bring those up. This example here shows you the type of cable that is attached to this interface. and its clock rate. So this is where you would look to see what type cabling you have set on your serial interface.